Hey guys, and welcome to the second episode of the crafting series. In this episode, I guess in the last episode, we set up this user interface for the crafting system. In this episode, we're going to be setting up the outline for the scripts, or just creating the scripts, and I'm going to talk about what each script is going to do. And we're also going to set up the types module, similar to what I did in the most recent version of the inventory system, where essentially we're going to define all the different object types that we're going to create using tables that will be applicable for this crafting system. And so that'll just kind of give us an overview of how this crafting system is going to work conceptually and how we're going to define, what is a crafting recipe, what are the different types of crafting recipes, and how does that work in like a 3x3 grid layout. So the first thing we're going to do, so with the inventory system, if you have it, then you should have this client, the client script, and then the server script. So there should be a local script and a regular script. If you don't have those, if you're starting with nothing without the inventory system, then you need to create a local script, and it's a really simple local script. So to create a new local script, name it client, and then you don't have to put this code in here. You can just ignore this because this is for the inventory system, and then do the same for the server, and same thing here. You don't need this code because all this is doing is it's requiring this module and then running it. It's running a function called start inside that module. So now that we have this client and server script, what we're going to do is we're going to set up a crafting server and a crafting client the same way we have for this inventory system here. So we're going to click plus, add a module script, and we're going to call this module script crafting server. And I'm just going to copy paste that in here and call it crafting client. So now we have these two module scripts. Let's see. And I'm just going to kind of restructure this a little bit. Not really going to change much. And then we're going to do starting. But I'm just going to do the same kind of layout that we have in the inventory server module, where we have this start function, right? And this function is going to be something we run right at the start of the game. That's kind of the idea behind it. So we have this basic code. All it's doing is creating a table. It's creating a function inside that table called start. And the function doesn't do anything at the moment. And then it's returning that table. So what we can do is if we go to this is the crafting server, by the way. So if we go to the server script, which is this one right here, then we can do, up here I'm going to do local crafting server equals require. And then we need to do the path to the module, so script.crafting server. So that will require this module, which will then essentially give us this value right here, which is going to be the table. And it's also going to run all this code right here as well. Let's see, so crafting server, and then we're going to run this start function. So that's going to run it at the beginning of the game. And I don't know if it necessarily matters which order you do these in, but there may be cases, if you continue this sort of framework I have with the server and client script, there may be cases where it does matter which order you start them in. And so that's something to keep in mind. But I think in this case, it doesn't necessarily. But just for safety, you could just do it the way I've done it here. So now we're going to do the same thing with the client side, basically writing the same code, but replacing server with client. So if we go over here, we're going to do kind of structure it the same way. And basically write the same stuff. So add a start function. And we're going to go to the local script right here. And essentially the same thing. We're going to do that here. Okay, so we're going to go up here. We're going to do local crafting client equals require script.inventory or script.crafting client. But in this one, I believe we're going to have to do this a little bit differently. Wiring modules. So I'm just going to set up a little section here, just kind of organize it. And then the thing with this one, from what I remember when I was setting up the system, is we need these to run at the same time because I believe the inventory client here, I don't entirely remember what the issue I ran into was. Okay, yeah, so I don't remember the specific details, but so there was an issue. So we can't do this in the client script because of how we're going to be setting up. We're going to make one slight modification to the inventory client which I think should be irrelevant if you don't have the inventory system, but I don't entirely remember. But it should be. You should be able to still be fine without the inventory system. And then with how we're going to set up the crafting client start function, we're going to need both the inventory client and crafting client to run the start function at the same time. Because if we do with my system, with how it's set up, then if you were to do this, then the inventory client start function is going to be waiting for something on the crafting client start function. It's like a signal call. It's going to be waiting for the crafting client to listen to a signal call, but the crafting client's not going to listen to a signal call until the inventory client, or until the crafting client actually runs. But the crafting client's not going to get to that point until the inventory client finishes. Basically, it leads to this infinite wait issue where neither of the scripts run at all. So we can't do this. Right now, it won't do anything if we did that anyway, because we don't have the script set up. But once we do set it up, we're going to have to do it a little bit differently. So we're going to start both the modules at the same time. In order to make so they run independently of one another in like different threads, so to speak. So we're going to create a table. That's just going to store both of these modules. So it just stores both the variables we have. And we're going to loop through that table. Just loop through all the things in that table. And then for each one, if module.start is not equal to nil. So if it has a start function, and type of module.start equals function, and that value is actually a function. It's not like some boolean or string or something. It's an actual function. If both of those conditions are met, then we can do spawn module.start. And the reason we need these is just in case, just basically to prevent any errors. Like if you ever wanted to expand this system and added more modules that you wanted to require at the same time, like with the task.spawn, then you'd want to make sure it doesn't try to run the start function for modules that don't have a start function, right? Because you might not necessarily need a start function for every single module, right? Anyway, so this is just kind of thinking in advance. And this task.spawn is just going to run this function. It's going to run this function, but it's going to do it in a separate thread. So that way it won't delay the rest of this code when this function is like waiting for something. So it'll essentially start inventory client 1 or whatever. Yeah, I guess it'll start with this one because it'll go through this one first probably. And it'll run the start function, but then before the start function finishes, it will run this start function, which then gets rid of the issue I talked about earlier that we would have run into otherwise. So this is going to be the client script. This is the server script. And these scripts are pretty much empty for now. So that's going to be the basic layout of the scripts for this system. Let's see. So now what we're going to do is we're going to set up the types module, and we're going to go over crafting recipes and setting up some example crafting recipes after we define the types for those. And just I'm going to show you how that's going to be set up. So what we're going to do, we're going to go over to replicated storage modules. And so if you don't have a modules folder here, then just go over here, create a new folder, name it modules. This is just from the inventory system. You're also going to be needing, I guess I probably should have mentioned this earlier, you're going to be needing these two modules, the janitor and the signal. They're downloadable on my Discord server as well as on a dev forum post I made. So I'm going to put links to those in the description. Make sure you download those and insert them into this modules folder. Anyway, these are just a couple different scripts. They're not really like, I wrote these, but I didn't really come up with these ideas. These are based on other scripts I've seen, but they're useful for a lot of things. The signal module basically handles remote events for you, so you can use strings and have it work with one remote event rather than a bunch of remote events, and just makes things a little bit easier to communicate between client and server, and even client server. Janitor just helps like if you have a lot of cleanup tasks you need to do after running some code, then it helps you organize those cleanup tasks and do them all at once. But they're relatively simple. I'll go over them as we use them as well. So you should be able to understand how they work. But close that. So then this types module, you're going to have to create this if you don't have the inventory system. So you create a new module script, right? And you name it types. I'm going to delete that because I already have types module. So what this is going to be essentially a storage of these type things. And if you're not familiar with this, that's perfectly fine because this is relatively new, this export type thing. Basically, what you're going to want to do in this module is you're going to set local types equals an empty table, and at the very bottom you're going to return the table, right? Same as usual for a module script, right? And then these are examples from the inventory system, so you don't need to add any of these. These won't be relevant if you don't have the inventory system. But essentially, what's going on here is we have this thing called a type. So if I just did like type example, you set it equal to what looks like a table, but it's a little bit different. Essentially, you specify a type of object. I mean, technically it's just a table, but you specify an object, like a way of structuring a table to sort of outline an object. And so say you wanted like a player data object, right? That would store the data for each player. Say it's for like an RPG game, right? So you'd have like, maybe this object would include the player for whose data it is, right? So it would be the string. This is like a string for the name of the property. And this is like the value. This is like the type of the property. So the type is a player object, right? So we would have one property called player, which would just be a reference to the player. And then maybe we'd have another one called strength, which would be a number, or another one called class, which would be a string, right? So you could add different things in here. You could even add like, you could add types within types. So you could do like inventory is a table of stack datas, right? Which is just this type right here. So you can get pretty creative with this type definition stuff. This export keyword is essentially just allowing you, because if I just use this type right here just on its own, this type would only be able to be used within this module script. So I could go like local player data example, and I can specify, so I create a new table. All this is a table, but I specify that it's an example type of object. And so that's going to essentially give me suggestions to like align with what I've defined here. So if I start typing player, it'll autocomplete, and it knows what type of object each of these values should be. You can see it'll autocomplete for each of them. You can also add like if you go to the top of any specific script, you can add like a comment and then an exclamation mark and then strict. And that'll make so if you specify the type for an object, then you have to align properly with what you've specified. So in this case, I would have to define a player, and that player would have to be a player object. So I couldn't do like a string, right? It's going to give me an error for that. And it's also missing all these other properties. But I won't be using that in this module, but I will be using that in some of the other modules. So that will come into play. But this is basically how types work. This export keyword essentially makes so you can use these types with like outside of this script. So in this case, it's a model script that can be required by other scripts or other model scripts. And it has all these export types that you can then use in those other scripts. So in order to actually use those in those other scripts, you need the keyword export right before it, right? So now we're just going to define some types for the crafting system. And I'm going to show you how we use that as we go as well. But we're just going to essentially define, like outline how this system is going to work. So I'm going to put a little comment just to separate this from the inventory system types. The first thing, let's see, what should we start with? So the first thing, we're going to create a type called recipe. And a recipe is essentially going to be, an outline for what it requires to craft a specific item, right? So if you had a table of recipes, it would be like, for each item, how do you craft that item, right? So the properties, we're going to have an item name property for the item that you want to craft. We're going to have a recipe type property. And this one, I'm going to call it string for now, but I'm going to change that in a second. And then a data property, which is going to be a table for now as well. But I'm going to change this one as well, because I want to be more specific. So let's do that right now. So local recipe, export type, recipe type. I'm going to call it recipe types, recipe type, just like that. I'm going to set this. You don't actually have to set these types to be tables necessarily. You could also do like a string. And so there's a cool thing you could do here. So I'm going to have 3 types of recipes, right? I'm going to divide this system into 3 types. There's going to be exact recipes. There's going to be movable recipes. Then there's going to be jumbled recipes. And so what I'm doing here is I'm specifying 3 different strings, and I'm separating them with this character right here. And that's just the character you get when you press the key, like the backslash key, but hold shift while doing so. I don't know what the name of that is. I kind of forgot. But that character essentially functions as like the word or, right? So a recipe type is a value which is either this or this or this. So there's only 3 possible values for anything of this type. So if I replace recipe type with, or replace a string type with recipe type, then if I had a new recipe, so like local recipe equal of the type recipe, right? And I set that to a table. The recipe type value, if I create a new string, it's going to specify that it has to be one of these 3 values. So that's just going to help make sure I don't like make typos and whatnot. So that's just going to help prevent errors in the future and whatnot. To specify, because we don't want just any string. We want one of these specific strings, right? We're going to do the same thing with the data. But before we can do that, we're going to create 3 more types here. So we're going to do export type movable recipe data, because we're going to have a type for each of the types of recipes. Jumble recipe data. And then here export type exact recipe data. Look at these. So we have 3 different types here, and we can do the same sort of thing here for this recipe's datas, recipe, or for the data of the recipe type, right? We want a table, but we want specifically one of these types of tables. So we're going to do another type here, export type recipe data. And we're going to do exact recipe data, movable recipe data, and jumble recipe data. And then we can change this to be recipe data. And that way this data property is going to be limited to one of these 3 types. Now we can actually define these types. And probably the easiest to define, I guess I'll go over kind of the idea of how these will work. The exact recipe is going to be, so we have this 3x3 grid, right? An exact recipe is going to make sure that every item is in the exact right slot that it should be. So for the recipe table, like for the recipe data, it's going to specify what item should go in what slot. And if a slot should be empty, it will specify that that slot should be empty, right? So basically, if anything is mismatched, then it's not going to match the recipe, right? And you're not going to be able to craft the item. So that's relatively simple to set up, but I'm going to do it in a very specific way that might seem a little bit weird, but it just kind of makes it a little bit more organized. So I want to create a type here called row, and I'm going to use this this T thing here. This is like generalized typing, something like that. Anyway, this is just sort of like a variable, but for a type. So we have this type called row, but the row can have various different. I'll just write this out and I'll explain it as I go. So we're going to do C1 for column 1. It's going to be of type T. So this T is a specific type, right? So C2 is going to be of type T as well. C3 is going to be of type T as well. So what this row object is essentially going to be sort of like an array of 3 items, right? Specifically 3 items, and with the keys C1, C2, and C3 rather than 1, 2, 3. And so why that matters, or why there's this T here, because I could just do like, row like this, and I could just do, like numbers, right? I guess in this case you'd want to do a string, because, you're doing recipes. So you'd want to have the names of each item in the recipe, right? So you could do this, and it would just be a row. But just to like make it more general, if you want to have other types other than string, and you want to use the same type definition for different types of rows, then you can specify, use these little arrow brackets, you specify a specific general type, and you can just use that throughout the type definition. And then when you create, so like local example, when you create a new object of that type, then you have to specify what type what type is going to go into this T value. So I want to specify maybe string. So I'll have a row of type string. And so now C1 is going to have to map to a string. C2 is going to have to map to a string. C3 is going to have to map to a string. But if I did number, then they'd have to map to numbers, right? So that's what's going on here with the the brackets and everything. We don't really need to do this for this system specifically, but I figured it'd be useful to do this, especially if we're using a very general term like row. But now you know, so that's the thing. So we have this row type. For this exact recipe data, we're gonna have 3 rows, and each row is gonna have 3 columns, right? So each row is gonna be of type row 3 string, right? I'm just gonna copy that. So now we have 3 rows, and each row has 3 columns of string values, right? And those string values are going to be the names of the item that should go in that slot, or just an empty string. Okay. So that's pretty simple to set up, right? Then for this movable recipe data, we're going to set up a different type of row. Actually, so we're going to call this row 3. I forgot to add that. I wrote it here, but I didn't write it here. So this is row 3, kind of named similar to like vector 3. Just kind of following that naming convention. Because a vector in math is just a list of numbers. So vector 3 is a list of numbers with length 3. It has 3 numbers. So that, I'm just kind of following that convention. And the reason I specify row 3 rather than just row is because I also want to have a type just called row. But with this one, this is going to be used for the movable recipe data. And it's going to have, the same sort of thing, except for one thing. We're going to add question marks on these second 2. Which essentially what that lets you do is you say like, so this row object, if you have something, local example, if you have something of type row string, then you have to specify at least one column, right? Column 1. You have to specify at least one column. But you don't necessarily have to specify, you don't necessarily have to specify columns 2 and 3. Because we have these question marks here, which means that these values can be either of type T or they can be nil. So you could just not include those. So this row, as compared to the row 3, is a row of length, is a list of length 1 up to 3, rather than just specifically 3. And the reason that's useful is because then we go to this movable recipe type, and essentially what we do is we say, okay, row 1 is of type row string, and then we're going to do row 2 is of type row string. This time with a question mark. Row 3, row string, question mark as well. And so essentially what I'm doing here is it's structured very similarly to the exact recipe type, but essentially, so say like I'll give an example for like what kind of recipe would be a movable recipe, right? So an exact recipe, if you're thinking about like Minecraft, for example, right, would be like a recipe for an iron pickaxe. You'd have a stick here, an iron ingot, right? There's no way you can there's no alternative way to craft the same item. You just put those items in those places and then you'll get the right thing, right? But if you're trying to make sticks from wooden planks, then, well, you just need to have a plank. But you can do that in any location. So you do plank right here, plank right here, plank right here. You can move it around essentially, right? As long as the planks are in the same relative position to one another, then you can move them wherever you want on the crafting table. And so that's what the movable recipe type is. And so I figured when I was thinking about how to set this up, I figured the best way to define that would be to think about just a smaller crafting table, right? So if you're talking about the stick recipe, think about a crafting table, or like a recipe that's just, rather than being 3 by 3, it's just like 1 by 2, right? Or 2 by 1, or whatever you want to call it. So the stick recipe would be 2 by 1 rather than 3 by 3. And so in terms of how the recipes are defined, the only difference between the exact recipe and movable recipe is that movable recipe can be less than 3 by 3. But we do want to include at least one item, right? So we have at least one row and at least one column. That's why these don't have the question marks on them. So this is going to be our movable recipe data, and I'll go into like how we'll actually use that, because that's going to be probably the most complicated one to actually set up in the script for like how it actually works. But I'll go over that when we get to that. But that's how we're going to define movable recipes. And then the jumbo recipes are going to be probably the easiest ones to do. All I'm going to specify is that you map strings to numbers, right? And so I'm going to add a little comment here. you map item names to the amount required. And what that means is essentially, like, think about, making wooden planks out of an oak log, right? In Minecraft, right? You just have one item, you put it wherever you want, and it doesn't really matter where you put it. Or think about, what's another example? Maybe like making fireworks, I think is kind of like that, where you just put sugarcane somewhere, or not sugarcane, you put gunpowder somewhere and you put paper somewhere else, right? And it doesn't necessarily matter the specific positioning of them, as long as you have the right amount of each item, right? That's what this jumble is going to be, right? It's just going to be, you put a specific amount of each item, and the order doesn't matter. That's going to be the easiest to actually script, right? That's relatively simple. So those are going to be our recipe types. I think that's all of our type definitions. Yeah. So now the last thing I'm going to do for this episode is I'm going to set up some example recipes that we'll be using to test this system throughout the series. And they'll kind of give you a better idea of how these types, like how you'll actually define recipes. So let me just do that. So we're going to create a new folder in this modules folder, right? I'm going to rename it to information. And I'm going to put more modules in here, but modules that are specifically used to just store information. I guess you could technically move types in there too. I think the only reason I didn't was because the inventory system is using it, and I didn't want to have to modify the inventory system. But we're going to rename this module to crafting recipes. And this is going to store all of our recipes for this crafting system, right? So what we're going to do, for one thing, we're going to use that strict keyword I was talking about earlier. So this is going to make so that anything inside this module has to follow, like if you specify a type for a value or for a variable, then you have to align with that type, otherwise it's going to give you an error. So I'm going to do module local crafting recipes, return crafting recipes. Cool. So that's the basic setup. I'm also going to require some services, maybe. Yeah, so I'm going to need the types module. In order to get the types module, let's see, local rs. We're going to need the replicated storage. You don't really need to like specify get service like I am here. It's just kind of a habit I've gotten into. Equals require rs dot modules dot types. So now we have a types module, and so now we have access to all of these different types that we've created. But I'll show you how we actually access them in a bit. But let's see. So I guess I'll start with this. So amount of items made per recipe. So we're going to create a small table. This isn't going to be the actual recipes itself quite yet, but it'll be important later on. So essentially, what it's going to define. So we're just creating a new table inside this module, right? Or inside this table, right? What this is going to define is going to define for each recipe. So like for an iron pickaxe, it's going to be one of our example recipes. How many items do you want that recipe to create, right? So when you craft an iron pickaxe, you only want it to make one iron pickaxe. But when you craft sticks, you want it to make 4, right? And same thing with wooden planks. And so that's what this table is going to be to specify. And you do need to specify this for every recipe that you have. Otherwise, I believe the system will give an error later on once they actually set it up. But you can add your own recipes into here as well. So like maybe you have like wild stew or something like that. If you have like a survival kind of game. And you can define that maybe a wild stew, when you craft a wild stew, maybe it gives you 3 bowls of it or something. I don't know. So then we're going to have 3 different tables. We're going to have one table for each type of recipe rather than one big table for all the recipes. So we're going to do exact matches. So local exact. And this is going to be a table of exact recipe data. So this is kind of a complex type definition here, but I'll go over this. So basically, so types.exact recipe data is how we access the exact recipe data right here. You have to do types and then dot. So it's kind of like it's adding the type inside the table. I don't know that it technically is. I'm not sure how it works like behind the scenes, but that's how you access that specific type. And you can only do that if I remove this this export keyword, then I don't think it would know what this is. Yeah, so it's not going to autocomplete now because it doesn't know what it is. But now if I add the export, then it knows what it is because it recognizes that can be seen from other scripts, right? So, and then this is just saying we're going to map strings to this type of object. So this is going to be, we're going to say like an iron pickaxe recipe, right? It's going to be mapped to an exact recipe data type. And you can see it's underlining everything, and that's because we have this strict up here, and because this doesn't match the exact recipe data type, because we don't have all the properties and stuff. So we're going to add R1 equals C1 equals. So this, oh my gosh. And then C2 equals, any commas. So that's one row, second row, and then a third row. And so now it's not giving that underline because now we have all the different pieces. So each of these rows, it doesn't like directly specify, but each of these rows, based on the type definition, is a row 3 of type string. And so I've just manually laid out what a row 3 of type string should look like, where it has the C1, C2, and C3, and they're all mapped to a string. And so this is where you're essentially going to define your actual recipe, right? So I've laid it out pretty nicely, so it just looks like the crafting table. And then, so for this, you put the name of each item, right? So iron ingot, and just kind of specify your recipe. And one thing that's kind of nice, because as you can see now, the type that stuff is kind of like slanted everything. So I'm going to add these as well. But you can see it's slanted everything, and now it's like it doesn't really look as nice anymore. You can use tabs to line them up, because the tabs normally they're of like a fixed length, right? But they actually line up with like specific sort of rows, or I guess columns. So that kind of lets you line them up nicely. You just do just the right amount of tabs for each line, and now they all line up, right? So that's pretty nice. And then that's the only exact recipe we're going to use in this series. You can add more if you'd like to, and you're probably going to want to add all kinds of recipes for your game and whatnot. But now, so we have this just as the local variable, but we want to actually specify that inside of crafting recipes. And the reason I didn't just do like crafting recipes.exact equals that, which you might normally do, and like remove this, and you might normally do this, but the reason I didn't do this is because then there's not really a way you can actually specify the type. It doesn't work to do like you can't specify type like that because this isn't a variable. This is something you're assigning a value to, or like you're assigning a value to a certain key in the table. So this is just a little syntax trick that lets you specify the type of this. Okay, so then that's our exact matches. So then we're going to do relative positioning matches. So local movable, and we're going to do the same sort of thing. We have strings mapped to types dot movable recipe data, and then our example recipe here is going to be sticks. And with this one, all we need is at least one row and at least one column of type string. So now you can see now it doesn't give me any errors because I have at least one row and at least one column. But I am going to add a second row. And in each row, I'm going to put wooden planks. And we'll have to like actually create these items. I haven't actually created these items yet, but that'll be relatively easy to set up. So now we just define the recipe for sticks, and you can see it'll always start in the top left corner. So that way, like if this was an exact recipe, it'd just be like you always have to put it in the top left corner. But how we're going to set up in the script is we're going to make it so where the top left corner is essentially relative to wherever the top left item is. So we're gonna calculate where the top left corner is based on the items in the table. So like if there's a wooden planks here, it's going to calculate the top left corner of the recipe itself as being right here rather than the actual top left corner. And then this is going to be like R1, this is going to be like R2, and this is going to be column 1 as well. So I'll get into that more later on, but it gets a little bit complicated. But the basic idea is it's relative positioning, right? So then, let's see, I'm going to put colons after these just because, or semicolons, just because why not? And then we're going to add the jumble recipes, which are going to be really simple. So recipes where positions don't matter, jumble, same sort of thing, string, map to types.jumble recipe data, wooden planks, wooden log. Cool. So that's going to be a really simple recipe. You put one wooden log in the table and you get 4 wooden planks, right? And the 4 is specified here. But if you wanted to have like maybe for like mushroom stew, right? I don't remember the names of items in Minecraft, but like you need like a wooden bowl, right? And then you need 1 wooden bowl, and then maybe you need like red mushroom, brown mushroom. I don't remember what the mushroom is called. I don't remember if that's actually what they're called. Anyway, so you can specify multiple items here. It doesn't need to be just one item, and you could say maybe you need 2 red mushrooms, right? So you have some creative freedom here. I guess the main limitation is that you can't have the sum of these numbers be more than 9. I don't think it'll actually give you an error message if you do, but the crafting recipe will be impossible if you do, because you won't be able to put more than 1 item in the same slot in the system. So do keep that in mind, but I'm just going to keep the wooden planks for now and just leave that as the only recipe. So then we're going to do, I forgot to do this up here as well. So crafting recipes dot movable equals movable, and then crafting recipes dot jumble equals jumble. We're also going to add some utility functions in here later on, but those are going to be a little bit complicated, so we're not going to worry about that for now. For now, this is our crafting recipes model, and it defines all the crafting recipes. And I think one thing I will do, I know I said this would be the last thing, but the last thing I'll do is actually set up these items, just because it'd be really simple. So let's see. So I already have the inventory system, so that it's going to have saving and loading already. So I don't want to use starter pack, because then it's going to duplicate items. But what I'm going to do to create these items, so I have this all items table. You're going to want to create this folder, not table, this folder, this all items folder. So go to server storage, create a new folder, call all items, because I believe I will be using that in the crafting system as well. And so I'm just going to duplicate one of these random ones. So the rock, I'm going to call this wooden log. Let me just open this so I can reference the names. Yeah, wooden log. And I'm going to change some of these properties. This is a resource, it's droppable, item tool. Yeah, okay, cool. And I'm going to duplicate that. Wooden planks. Duplicate that. Sticks. Duplicate that. Iron. Pickaxe. And this one is going to be specified. I'll just call it a weapon. But it's not really going to matter in this. If you're not using the inventory system, it's not really going to matter. Like you don't need these attributes and this tag that I have. This is for the inventory system. So if you don't have the inventory system, just all you need is plain tools, and you can do whatever you want with the tools. Have them function however you want. But to make it work with the inventory system as well, I have these added as well. So iron pickaxe, wooden log, sticks, wooden planks, and what else? So we need iron ingot. I think that's all the items. So I'm going to take all those items that I just added. I just kind of stylize them a little bit. Really basic. I'm just too lazy to do much with them. So they're all just tools. You can customize your tools however you want to customize your tools. So I'm going to take all these items, I'm going to cut them with Control X. I'm going to delete their original ones. I'm just going to replace them. Cool. And I'm going to copy those again. I'm going to place them back in the workspace. Just so I have a copy of them in the workspace that I can use for testing. Oops. So now when I run the game, I can actually go and I can pick them up off the ground. I need to set up the UI so it doesn't stay open, but I can pick them up. They all have the same image. I'm going to worry about that later, probably in the next episode. Anyway, so that'll be the end of this episode. I hope you enjoyed. Sorry for the delay in releasing the second episode. I got a little bit caught up in some stuff. If you're interested in downloading the files, the completed files for this system, as well as files for other systems like my inventory system, you can get access to all the tutorial files for my videos through my $299 a month membership on YouTube or Patreon. And there's more information on that in the description if you're interested. Additionally, with the higher memberships on YouTube and Patreon, then you also have the option to get personal tutoring with me, just over like a voice chat call or something like that, where I can work one-on-one with you on whatever you want to work on, and I can help you with your game. I can teach you specific concepts you want to understand better, whatever it is that you want. Either way, though, I hope you enjoyed this episode, and I will see you next time.